Hi, my name is Daniel Monforti. I'm an application engineer with RIGOL Technologies, and today I'll be demonstrating a few simple tests you can perform on antennas to help you choose the best antenna for your Internet of Things application. Since I'll be using Bluetooth later on to send information, I want to double check that our antennas are rated for the 2.4 gigahertz bandwidth. So to start off with, I have two antennas. I have antenna A and antenna B. And I'm going to start off with performing to see if they're rated for the 2.4 gigahertz bandwidth by attaching antenna A to the transmitter on our spectrum analyzer, and then going and hitting TG, and then turning it on. At this point, it's doing a full sweep of the entire spectrum, and just getting the power being transmitted and capturing it on the secondary antenna. I'm going to go over to the peak section and see if this is rated for the 2.4 gigahertz bandwidth. So I'm going to actually bring it over there. So we're right around there. So as you can see, this antenna is rated for the bandwidth we'll be using. Now to do antenna B, the same test. And let's bring this. And as you can see as well, this antenna is also rated for the 2.4 gigahertz bandwidth. So both are able to function in the Bluetooth, Wi-Fi, or Zigbee realm. For our antenna performance test, I use our DSA 875TG spectrum analyzer. But if you are testing in the 2.4 gigahertz bandwidth for either Bluetooth, Zigbee, or Wi-Fi technology, you can certainly use our DSA 832E TG spectrum analyzer, which has a range of 9 kilohertz to 3.2 gigahertz. In order to get a sense of how these antennas will do at the 2.4 gigahertz range, I'm going to perform a VSWR test just to see the reflection coefficient and how well they're performing and how efficient they are. To do this, I'm going to hit measure. Actually, first I'm going to hit frequency and change this to 2.4 gigahertz. Then I'll hit measure and turn on VSWR. And then I'm going to go into measure setup and hit cal open. And then I'm going to attach our antenna A to the VSWR bridge. And then I'm going to go ahead and hit VSWR. So right now it's performing right around 10 or so for VSWR. Ideally we should be looking at around 1. So this is reflecting quite a bit of the signal that's being pushed into it. Now we'll compare this with our antenna B. Which this actually has a VSWR of right around 1 or so. So this is actually a lot more efficient than our antenna A. So I would assume that this would actually give us further distance and would use less power. For our VSWR test, I used our VB1032 VSWR bridge, which has a range of 1 megahertz to 3.2 gigahertz, along with our spectrum analyzer. In order to show how the reflection coefficient will have an effect on our two antennas, I've connected antenna A to our Nordic NRF52 board, and I'm now going to connect it to my iPhone. And then I'm actually going to show how the distance is affected between the two. Antenna A dropped right here, so now I'm going to go see how much farther antenna B will get us. Now to perform the same test, but now with antenna B, I'm going to connect my iPhone to the Nordic NRF board, and now we're going to go outside. I'm now using antenna B, and I still have connection where antenna A dropped. And I'm going to go a little bit further, and this is where antenna B drops. So we got about 8 to 10 feet more of distance, but if you don't need the distance, you can always go ahead and save power. The total cost to perform all the tests shown in this video at the 2.4 gigahertz range is a little under $4,500. If you have any questions regarding the products seen in this video or any of our products, please contact us at RIGOL or visit rigolna.com for more information.